So what is inferential stats? It's nothing but you can say you're deriving some outcome from the sample, which means we have some population data and we need to compare some after event outcomes. We can use inferential stats to validate the changes in population by using samples. So in definition wise, if you see, it's nothing but it's a prediction or it's inferential about population. It means we did some event on a set of data sets, and we want to validate if any differentiation is available after the event, or if you want to analyze the group or subgroup variations, sort of things. So in that case, we can use inferential stats to validate this population sample data points. So primarily, it extends beyond the merely describing the characteristic of data set, which we did in the case of descriptive stats, mean, mode, median, standard deviation. Yes, that is required, but that is not the core objective of doing inferential stats. Inferential stats use the descriptive stats data points and help to draw the conclusions about the group of data sets. Group of data set could be in form of independent sets, so it could be a dependent set, so depending on the test which you are performing on the set of data points. So we'll see various stats, various tests in subsequent slides, which comprise the specific set of data values, and we use data values to validate our test. So key concept which we will be including is first population sample, the same which we included in the descriptive stats concept also. It is similar to that. Parameter and statics. So parameter is nothing but a numeric value in general terms, if you say. And we generally prefer parameter in terms of population data set. We're using in sample data set, we use statistical values like mean, mode, median, sort of things. If we are using sample data sets. So parameter numeric values describe the characteristic of populations, whereas the statistical data points are which describe the characteristic of sample sets. So you can say parameter is meant for population, statics values are meant for sample in general terminologies. Sampling techniques we had already seen, random, stratified, and other things are there. So we'll see one by one. Then very important thing is that the hypothesis testing is a normal, let's say, term we'll be using in subsequent slides. Hypothesis nothing but let's say it's exception, it's an assumption which we take while we start doing any inferential test. Likewise, in the case of t-test, chi-test, and ANOVA, we have different hypotheses which we are validating. So hypothesis, it's an assumption to start with. It means we are managing a status quo. We call it null hypothesis. If we are validating any change in status quo, we say alternate hypothesis. We will discuss in detail in subsequent slides when we take any specific inferential tests. And the next topic is inferential test. We will be including t-test, ANOVA test, and chi-square test in this series. Although we have other tests also which we can test across. Next point is significance level. You can say it's a probability, or it's a threshold which we take to validate our outcome against a table values. In general, 5% significance level is what we accept as a threshold to validate my hypothesis testing validations. And based on significance level, we drive our p-values. P-value is nothing but the probability of significance. Means what is the probability we have to get this differentiation available in a test. We'll see in detail. Confidence level is a threshold value which include negative and positive threshold points under which if our data is there, we say that our null hypothesis is true, or if data is going beyond the interval given, we'll say our alternate hypothesis would be let's say termed as true. So population sample, parameter stats, sampling techniques, hyper-testing, inferential stats, significance level, and p-value and confidence levels are things we will be including in the